Hi Vijay sir, you can start. We are live on YouTube. You can go ahead.
Okay. I'm not able to share my PPT yet. Could you just give the host permission?
Yeah, given to you, sir.
Yeah, sure. Thank you. Thank you so much. So I hope my voice is audible to you all. If you have any issue with the audio at any time, please.
No, sir. Audio.
No, sir.
Yeah, please feel free to put it on your chat.
Sir.
Yes, sir.
Yeah, please wait for another minute.
Okay, sir. Sir, somebody is drawing on.
Yeah, I'm just trying to
Disable the option, sir.
Yeah, I have disabled the option. Yeah.
Drop it, sir.
Is it going off? No. Okay. Lakshman sir, could you just help me with disabling and?
Sir, you have to erase this drawing, sir.
Disabling annotation, sir.
Yeah, I have disabled the annotation, but somebody has drawn already, I guess.
Yeah, already it was done. Please you erase yourself from your side.
Okay, let me just try.
Hereafter it is not going to happen because already on disabled.
Sir, erase all, sir.
Yeah, sure. Okay, I think now we are fine to go.
Yes, sir.
Yeah, so a very warm welcome to you all onto the third lecture. So let's first of all begin with muting all. So you can put all your questions into the chat box and we shall answer them towards the end. Okay, so we are ready to go. You are free to post your questions in the chat box. We'll be looking into that. So today's topic is going to be a continuation of what we did in the last lecture. It is last lecture we talked about the completion of the whole. So this time we are going to complete, but this time we are going to complete with a picture. So you must have played this particular game in your childhood. So this is a useful exercise to begin with. So here you see a stream of numbers and the job is to just connect all of these. So how do we start connecting? We start from the number 1 and then start connecting. Let us try this out. Okay. So we start from 1, we go to 2, we go to 3, 4, 5, 6. From 6 we come back to 7, 8, 9, 10 and back to 2 this time. I should have put 11 here in order to indicate. This approximately resembles the shape of a leaf. So if you are given an approximate picture in the mind, you are able to complete it. So that is the idea that I wanted to take forward. So this is that idea in the form of a game. Now, a beautiful story can be told to drive home this idea further. So have you heard about the story of 6 blind men and an elephant?
No, sir.
No, sir. This is a very interesting story. A group of 6 blind friends went to a zoo to see an elephant. So they have never seen an elephant prior to that. So each person went near the elephant and caught hold of one of the elephant's parts. So as you can see in this picture, one of the fellows got hold of the horn and one held the trunk. The other person was holding the ear. The other was near the main body part. One of them was near the leg and the other was near the tail. So 6 friends positioned themselves. They got hold of one of the parts of the elephant. Now, what did they think? What were there? This is an interesting thing. So the person holding the tail part told that it is a rope. The person in the main body told that it is a wall. And the person's answer who was holding the leg was interesting. He told it's a tree. So nobody appeared to know what an elephant is, and they were speculating something that they had already known. So sometimes in our case also, students, while they face mathematical problems, they seem to be not getting the complete picture. So it is very important that we step out a little further and look the complete thing and then go and solve. So in this particular course, we'll be emphasizing on this techniques 2 and 4. Like we'll be coming to this technique gradually, but you should always keep this complete picture in mind. So in the case of addition, we have seen how to complete the numbers. So an example is given here. Suppose I want to write 10 as the sum of say 3 distinct numbers. Here I have put 3 boxes. The first box has been filled already for you. Now the task for you is to complete, say, for a number like 20. So I have taken the right hand side in such a way that it is a base of 10 or a multiple of the base of 10. So is it possible to add 3 numbers to get 20? The answer is certainly yes. So I'll add a little bit more constraints. So you have to have at least one 2-digit number, and the other numbers could be anything.
Sir, your voice is double. 1 plus
So
1 plus 18.
Possible to add some
18 is a
issue
double.
with the audio? Certainly yes. So I'll add a little bit more constraint.
Sir?
So you have to have at least one 2-digit number.
Sir, your
audible
voice is
now?
double.
And the
Sir,
other
your
numbers
voice is
could
double,
be,
sir.
the other numbers could be.
Sir, your voice is double. Sir, your voice
I'll
is
just
double.
check. I'll check.
1
Just
plus
check
1
with the.
plus 18.
To add.
Please stop. Sir, your voice is double, sir. Sir, you have to keep all mute, sir. Sir, your voice is double.
Yeah. Is there a someone
Sir, your voice is
technical who can
double.
help me with this?
Double, sir.
Lakshman sir. The other numbers.
Sir, I don't
Sir,
understand.
your voice is double,
Somebody
sir.
are talking.
Sir, your voice
I'll
is
just
double.
check. I'll check.
1
Just
plus
check
1
with the.
plus 18.
Please stop.
I hope
Okay,
now. I hope now it is okay. Is it
Okay,
fine?
sir.
Yes, sir.
Yeah. So I have muted all. Kindly don't unmute yourself until the end of the session, until I speak. So we are going to find out 3 numbers that are going to add up to 20. The constraint that I have
Sir, your
put.
voice is double, sir.
Please stop.
Sir, your voice is clear on.
Is it okay right now? Is it audible right now? I hope now it is okay. So let us jump directly into this. So I say one of the numbers is going to be say 14. Can you fill in the other 2 numbers of your choice? So I'm going to fill this with 5 and 1. So So now let us go into a little bit more difficult one. Let's put 25. The constraint here is that I'll add two 2-digit numbers. So I have to have two 2-digit numbers. Again, this is going to be summation. So if it is two 2-digit numbers, I can do 11 and 12. So that makes it 23. And the remaining number has to be 2. So this is how you can tackle problems that has some constraints that are given. So by constraints, what I mean are some conditions. So in usual mathematical problems, you have some kind of conditions in place, which means that you have to accommodate these conditions while you solve for the answer. We shall detail in this as we approach some of the problems. So this is a little bit more continuation from what we did last time. So last time we drew what is called as a number line. And in this number line, we can represent these numbers, say 49. So 49 is very close to the base 50. Now, if I want to add 5 to 49, what I can do is that I first reach the 50 mark and then march 4 more. So this is how in cricket you will see a batsman wants to get a half century. So first he gets the enough scores for half century and then he proceeds. So you can see a similar analogy that is coming here. Now, I want every one of you to think in your mind how each of the numbers can be made closer to the base. So in the first case, the base was 50. In the second, it is going to be 60. So you have to borrow 2 from 3 and then you have to march 1. So this is how you can make addition a lot more smoother and easier. I will leave the other two problems for you to think about. You can think in your mind. We shall not solve it here. You can do it after the class. Now this class is full of stories. So we are going to start with another story. So do you want to hear this? So this story is about the hungry Hari. So he wants to eat a lot of things. So last week you had the Dasara. So his mother promised him that she will give every day of the Dasara festival. There were 10 days, and every day she would give him some number of sweets or some gifts. So she also knew that Hari had joined for this Vedic Math class. So she wanted to test him a little bit. So at the end of the day, Hari had to tell her mother how many gifts he has received till that day. So from day 1, if he has got one gift, at the end of the day, he has to say he has got one gift. At the end of day 2, he has to count the total number of gifts that he has received till that day, and so on and so forth. So here are the gifts that he has got. It's a very interesting piece of question. So on day 1, he got a laddu, and that's only a single laddu that he got. On day 2, he got 2 sweets. In fact, 3 sweets. So on day 1, he just got 1. On day 2, he got 3 sweets additional. So at the second day, he would have to say he got 4 sweets. Now like this, it went on. He was able to calculate this for a few days. But after that, he was also instructed that he was not supposed to write anywhere and tell the answer. So this made him a little bit shaky. So he thought that whether he can get some formulae like the sutra that we have, is it possible to get some formulae so that if he plug, say in day 5, how many sweets he has got, till day 5, how many sweets he has got, is it possible to tell his mother? Now, at the end of day 10, he has to say how many sweets he has got in total. In fact, mother said that if he has to get the sweets for day 10, he has to correctly say how many sweets he has got till day 9. So let us see if there is some pattern in which these numbers are progressing. So in fact, he got one gift in the first day. He got 1 plus 2 gifts on the second day. And on the 10th day, as per the statement, you can see 10 plus 9 plus 8 plus 7 plus etc. This goes on up to 1. So this is the total number of sweets or gifts that he got. Now he wanted to see whether there is a inbuilt formula that he can get, so that just plug in day 5 how much he got, that would give him instantaneously the answer. Let's see if we can help him. So he approached another friend, say Madhu, and he asked whether he will help him in solving this problem. So you can see in day 1 he got 1. In day 2 he got 1 plus 2. In day 3 he got 1 plus 2 plus 3. So on. In day n he would have got, so this is the third day. Day n he would have got plus etc. up to k. So do you think that he can find a formula that can directly help him to say the answer? Let us figure out a little bit more. What is this sum? This is 3. This is going to be 6. So is it possible to generalize this for k numbers? The answer is yes. Some of you might know the sum of k consecutive natural numbers starting from 1 is going to be k into k plus 1 upon 2. So this is a standard process. If you want to derive this from the starting, you can just check by the method called as induction. We shall not get into the details now. You might gradually learn in the courses you take in mathematics. Now you can put k equal to 2 here. The answer is going to be 3. K equal to 3 here. The answer is going to be 6. So that is a way to verify this. Now he has to sum this up to day n. So if he is going to repeat this for n days, he has to take k equal to 1 to some number n. Now I'm introducing a little bit of notation, so you'll have to bear with me. So what this notation, sigma, some of you may find it a little bit difficult to digest in the beginning. This is just representing that I should add these terms that I have put in brackets. So n, suppose it is going to be 3, I have to add 1 plus the first bracket, which is 1 plus 2, plus this second bracket, 1 plus 2 plus 3. So we are going to put this as k into k plus 1 by 2. Now for the time being, I'll just do some hand waving and write down the answer for you. So this is going to be 1 by 2 into summation of k squared plus summation of k. I'll put down the final answer. So this is going to be 1 by 2 times n into n plus 1 into 2n plus 1 by 12 plus n into n plus 1 by 2. Now the reason I'm bringing this question is that in a lot of competitive exams, you will have to deal with such summations. This is something called as adding consecutive numbers. So you will have to learn these up and familiarize with the notations. Now, easily, Hari can put each day's number here and figure out what is the answer. So let us find the answer for the 5th day, how much chocolates or how much sweets he has collected till the 5th day. So you just have to put n equal to 5. This would imply he will have total gifts is equal to half into 5 into 6 into what is 2n plus 1? 2 into 5 is 10 plus 1, which is 11 by 12 plus what is this? 5 into 6 by 2. So let us help him out. Here we'll use a little bit of our Vedic mathematics. So we know 6 and 12 are going to factor. So we get 2 here. Now what is the remaining number? 55 plus, in fact, I have made a little bit of silly mistake here. This should have been 6 in the formula. So this would completely factor out. So I was just taking 2 and 6 together to write 12. So this should be 1 by 2 times, in fact, 55 plus 30 by 2. Am I still going out? So this should have been 55 plus 15 and 1 by 2. So none of these numbers factor 2. So we'll have to find this out. So this is 70 and half of that is going to be 35. Now to speed up the calculations, you could have little bit more of advantage, which we'll talk in a little bit from now. So hope you enjoyed this story and the mathematical concept that was driven behind it. We'll continue with some more calculation. This time we'll do it in the mind. Now we are going to larger numbers here. So if you have two 2-digit numbers, how do we add? So one easy way we can find the base of 48 or the numbers that are closest to the base. So this can be written as 50 minus 2 plus 45. Now it is easier to add numbers near the base. So you can add 50 with 45 first and then subtract. So this is 93. So conventionally, what you would have done is 5 and 3. That adds up to 13. You would have 1 as the carryover. So in Vedic mathematics, we do not usually rely on carryover. But if it is for larger calculations, we have a special method of representing carries, which we'll come to shortly. So let us do this second one. So we have 6 and 6. One way to take this is 56 plus 24. Remember the 10-point circle. So 6 and 4 are complementing each other. So you take a summation which has 6 and 4 and then you take 2 towards the end. So how do you add this? So this is 82. You sum the first two numbers. Now the relation that you have to keep is towards the base of any number. Now there are two bases for any given number. One is called as a local base and the other is what is called as a true base. So local base is the nearest multiple of 10, which is closest to the number. And the true base is the number that has to be definitely 1 followed by zeros. So if you take a number like 48, its local base is going to be 50. Its true base is going to be 100. So local base of 29 is 30. So you can write 29 as 30 minus 1. So 30 plus 36, you know, it's 66. So the answer is going to be 65 because you have to take 1 off from 30. What about 37, 47? They are close to their bases by 3. They are 3 below there. respective bases. So the bases are 40 and 50, that makes it 90, but you have to subtract 3 from each. That means you have to take 6 in total. So that is 84. So this is how you can speed up a lot of additions. Now, this is also another way of driving home the same concept. Have you seen in roadsides, you have seen paper cans where you can put your waste. In fact, waste boxes where you can segregate these wastes. So in numbers also this is true. You have to segregate some set of numbers together so that it collects together to form a base. So we are making use of this idea of segregation. I'll just help you with the first, the others you can do at your home. So 1 plus 19, that would collect to the base, which is 20, and then 8 is there, 28. So all this has to happen in your mind. So this is a gradual process. So I urge you to try some of the practice questions that are available in the Practically app as a part of this Vedic mathematics course. So let us try larger numbers. Let's begin with this 3-digit addition, which is on the right side. So when you have a list of numbers, usually you will see such numbers in a supermarket bill. So this is how it looks like. Now, if you want to tally the bill by the time the cashier prints the bill, you have to be a little bit smart. So this is how you can smartly do. Traditional mathematics teaching will tell you to start from the right side and you count so that you will reach a number, and if you have carry, you put it on the other side. Here we are a little bit different. We start from the left side and we add up all the numbers immaterial of what carry comes on. So let's start adding. Here you have to add fast. So collect all the numbers that are going to be connected to the base. So 3 and 7 makes it 10. Again, you get 3, 2, which is 5. Another 5 is here. So 20, 21. So we got 21 in the left side, leftmost digits if you add. Let's see if there is an easier way to add up these on the central row. So 2 with 8 makes it 10. Then there is another 4 plus 4 plus 2, which is 20. Again, you get 21. This time we are going to represent a little bit differently. We'll write 1 and 2 a little below, saying that that 2 is not meant for that middle place, but it is required for carrying it over to the next digit. Similarly, let's do the third one. We are going from left to right. Now the rightmost column, you can easily find numbers which connects to the base. 1 plus 9, 10. Now there is a 2 here, there is a 1 here, there is a 7 here, which means there is 20 in total and there is 26. So this 26, we are going to put 6 as a large number, 2 as a small subscript just on the left side of 6. Now, so the answer is very direct. So 2 should be carried over to the 21 on its left. So this is 2, 3. This 2 should add with 1. So 3 and 6. So this is how you can do it smartly. So for this, we require a gradual practice. So whenever you observe numbers around you, try to do this mental calculation. You can begin with smaller numbers. So I leave the 2-digit numbers for you to compute at home. Let's take this, another example, where it is a worded problem. So some students will especially find a lot of confusion while reading word problems because they see that there is some amount of confusion that is left in the problem. So in order to avoid that, we'll read step by step what is given in this problem. So there is a person called Sammy and his mother has gone to some shop to buy some groceries. And The grocer has given the final amount and Sammy has to tally them. So there are 4 products. The products are not important. So the idea is to collect the important things. The important things are these 4 numbers. Now we are not going to touch the pen or paper for this. Let's see if it is possible to add this up without it. So you can carry the 6, you can split it as 55 plus 1, and that 1 you can give it to 89. That makes it 90. And there is a 5 from 55 that you can give to 35 to make it 40. So you have got 3 numbers, 90, 50, and 40. So which adds up to 180, and what you are left with is 72. So this is 252. You can verify for yourself. Let's go to the next example. This is actually a problem that I had given for the puzzle for you to sum it up. So I have kept an objective problem which will appear after this lecture in your Practically app. You can just try to solve for this. So let us proceed a little bit more. Where are these actually going to play a role, these additions? A little bit more difficult level will be to add decimal numbers. So how do we do decimal numbers? The first idea is to forget the decimal place, add it, and then put the decimal place back into its original position. So 4.37 and 2.55. So how do you start? You can first take the decimal part alone. You see that it is not going to exceed 100. In fact, what is it? So if you add 40 to 55, it is 95, but it is 3 less than that. So 92. So decimal side should be 0.92, and the remaining part should add up to 6. Let's try the second one. 4736. Let's make this 50. So this adds up to 86, but we have taken 50. So 3 has to be subtracted. So it has to be 83. So this if it is in rupees, it is 83 paise. Now 2736, again you can use the same rule. Make it 30, so it becomes 66. 63 because you had additionally taken 3 for making it 30. So this is 63. Now things get a little bit more difficult if there is if the number in the decimal place exceeds 100, or if it exceeds or if it carries over. So 55 plus 75 is one such example. So here, since every number ends with 5, it is easier to add. So 50 plus 70 is 120, and there is 5 plus 5, which is 130. Now that 1 will carry over. So you can directly write that as 5 plus 8, which is 13. And what remains is the 30. The last example is also similar to that. Here you can add 7 and 8, which is 15, or 150, and there is 159. So 59 remains here, and the other gets carried over. So these are all simple tasks, but if you do it in the mind, you'll get to practice. And this practice would eventually lead to saving a lot of time when it comes to competitive mathematics. So we have a few more simple rules which we can keep in mind. Some of them might have been discussed. So if you find numbers ending with 9, it is always easier to write it as base minus 1. Here it is 10 minus 1. So to add 33 with 9, you just have to add 10 first and then take away 1, which means this is going to be 42. There are a few practice problems which will appear as part of your practice set in this week. So if it is numbers other than 9, how are you going to deal with it? We have already considered them in some of our previous examples, but just for the sake of revision, let us do this. So 18 can be represented as 20 minus 2. So 20 with 4, 44 would be 64, and you have to take 2 away. So this is going to be 62. So there are no carries that we are dealing with in Vedic mathematics. And there is a very useful result which we can use as a part of subtraction, which is more difficult because you have to borrow and lend. So Vedic mathematics avoids all these borrowing and lending. All of these are taken care by sutras. So 44 plus 27 is the next. So first add 30, that would be 74, and 3 is taken away. So that is 71. Let's do one more. 55 plus 28, again add 30 and take 2 away. So 85 minus 2, which is 83. Now we'll see how to do subtractions as well. In this example, 44, from 44 we subtract 90. Now 90 we know it's close to 20. So we subtract 20 first, it is 24. But then here we have to note that the number taken away is more. So you have to give back. So the answer has to be 25. So simple rules that will help you fasten your calculations. So 90 minus 66. How do we do that? 90 minus 70 is easy to do, which is 20. So 4 is the difference with the base. So you have to give back 4 to it. So the answer is going to be 24. So no pen paper required. You can directly do all this in the mind. 55 minus 27. First subtract 30 and give back 3. So 30, that means 25. The answer should be 20. Here are a few more practice problems. Again, you can access these in the app as a practice set or practice quizzes. So I urge all of you to have a look into the Practically app, Vedic Mathematics course. After finishing with this lecture, you can see some of these appearing. So to summarize in this particular session, what we have seen, or up to the lectures 1, 2, 3, what we have seen is an introduction to Vedic mathematics. In fact, we have not dived a lot deep into this subject. We have just constructed some foundations. And this foundation was set with the 10-point circle, where we saw the importance of what is called as the base of a number. Then we introduced what is called as a 9-point circle. And then we saw what is called as the number system, where you can identify each of them and take its complement. Now this complement is a little bit advanced topic which we'll take up in a later lecture when we do subtraction. Then we saw how we can add numbers when it is deficient from the base, and this complements our present topic, which is to complete the picture. So a lot of emphasis needs to be given on practicing these problems with on your head or on your mind. So you have to do a little bit of practice each day with whatever subjects you are dealing with. If you encounter some kind of numbers in it, take a challenge that you will first try it without pen and paper. Figure out whether there is some completion patterns that you can observe. So this is a beautiful quote that was present in the Vedic mathematics textbook that was written by Sri Bharata Tirthaji. So he went to take this class, and after this, students came joyfully dancing and told him that the answers are written down without any intermediate steps. So the teacher was actually a lot more happier to hear this. So try yourself to do a lot of mathematics on your head. I just want to end with a small puzzle which will appear in today's app after this lecture. This is just to introduce you into a little bit of competitive maths. So competitive maths is a set of problems which you will get in order to solve, so that you will create a kind of interest in mathematics. It will create an interest for you to solve higher complexity problems. Now, the problem that is given here is similar to the idea of the topic that we dealt here to complete the picture. You can see numbers 8, 6, 8, 13. I'll just help you with some variables. You can put this variable as x, this as y, this has some u, and this has some v. If you have learned solving linear equations, this would be a easy question for you. You have 4 variables, 4 equations. If you want to think from Vedic mathematics point of view, this is something like completion. We take 2 numbers. We started this lecture by figuring out 3 numbers which add up to 10 or 20 or 25. In a similar manner, is it possible to guess these numbers? So I want all of you to try this question after this lecture. And I'll leave you with a harder problem also today. This is for those students who have learned a little bit more of mathematics like prime numbers. This is a little bit more intense. So I have marked the level as hard. This is not meant for all students. So you can read through this question regarding prime numbers. So with that, I'll open the floor for questions. So you can kindly raise your hands if you have any questions, and I will unmute yourself. So I can see some raised hands already. So Bhargav, you can unmute yourself and please ask your question.
Sir,
Yeah, please go ahead.
sir, in before class you gave one problem in practically like homework, na sir? Test
Yeah.
1.
Yeah, sure. So every day after every day's lecture, there would be a puzzle that would appear in the app. So due to shortage of time within the lecture, I would like to give the solutions for that in a separate video or a lecture. So kindly wait till that. Kindly wait till that moment. I'm trying to give the solutions as a part of this app or app itself. If you complete that assignment, you will see the solution appearing. So kindly wait for maybe two more days until you get the solution.
Okay, sir. Thanks.
So I'm very happy that some of you have tried these puzzles. Keep trying a lot of puzzles. It will engage your mind, and this is how you can improve your practice. So anyone else with some questions? We have almost 4 minutes left. So if you have no other questions, let me just give you some understanding about this last puzzle. So prime numbers, as we know, are numbers which do not factor. So a number that has 1 and itself as the factors are known as prime numbers. Let us do a simple search of prime numbers from 1 to 10. Now 1 is not a prime number. 1 is neither prime nor composite. So let us start listing some of these numbers. It is very useful. So 2 is the smallest positive prime number. Then what is the next? 3. 5 is a prime number. Why is 4 not written? 4 can be written as 2 into 2. That's why it is omitted from this list. The next prime number is 7. So you can see, except for 2, all the remaining numbers are coming as odd numbers. This is a very important thing to take away. What about 9? 9 is not prime because it is 3 times 3. So these are the numbers that are below 10 and that are prime numbers. Now there are some interesting results that you get. If you add any 2 prime numbers except 2, you will get back a even number. Like this, there are a lot of properties that are available for prime numbers. You can just check that out. So I see one more question from Pavan. You may unmute yourself and please ask. Somebody else with the questions? So I don't see any raised hands. I'll just check with the chat box. It is very difficult to follow in the chat box, but still, I'll just have a look into the chat box as well. Yeah, it's good that some of you are answering in the chat box. So I can see a lot of answers being written. Keep doing that. So we'll come up with some kind of what are called as points as we go ahead in the subsequent lectures. We'll come up with some improvements in the way we interact. So until now, the plan is like after each lecture, you will have some practice problems where you will have to interact with the app. So give your solutions. Some of the questions that will appear are subjective, which means you will have to either give the answer, type in the answer, or you can just scan your answer, which is written on the paper. So I'll try to have a look into your solution. And I'm also giving you an option of solutions which are either in the form of explanation. It can be, if it is a common problem for many, I can have a video for that as well. So this will be the plan as we go ahead. So I once again thank all of you for joining this. So we'll see again some more topics tomorrow. Until then, thank you and namaste.
Sir, tomorrow morning at 10:30, sir.
Yeah, tomorrow's session is at 10:30 in the morning. So kindly join a few minutes ahead of that.
Okay, sir. Bye, sir.
Thank you.